Welcome to the only YouTube series where you will learn Android programming concepts in under 15 minutes. In today's video we will look into the core concepts for programming in Android, namely the language and one of the UI frameworks, Kotlin and Jetpack Compose. Together these two will give you the understanding and tools you need to create your own first Android application. 15 minutes, here we go! Android applications used to be developed in Java. And although this is still possible, Kotlin is becoming more and more popular. If you still want to learn how to program Android in Java, there's another playlist on this channel that you can find in the description. One of the big problems encountered in Java is no pointer exceptions. In this case, you are able to reference an object that hasn't been initialized yet, which will give you runtime errors and cause your applications to crash. Kotlin helps us avoid these errors by creating null safety. This means that apart from the type of a variable, we also have to initialize whether it's nullable or not. And we do this using a question mark. This way, Kotlin can check in your code if you should handle null cases, and it prevents you from having runtime errors. For example, when we have to define a string, we use a variable of myText, which will become a string, and we use the question mark to say that it's nullable. And then we can define or initialize it as null. Then when we want to show this text on the screen, we say, okay, we have some sort of text composable, and we say the text is myText. And Kotlin will show you, hey, this can be null, so what do I need to do if it is null? And then you use your else operator, or the question mark followed by a colon, to define what happens when it is null. In this case, empty string. Besides its null safety, Kotlin in general is also more robust and more concise, which makes coders like me generally happy because we tend to be a little bit lazy. Now that we know why Kotlin is so popular, let's look at some of the basics in Kotlin. Firstly, Kotlin has immutable and mutable data types, which we can define using the val and var keywords. As you see, we also have to define which type of variable a variable will hold. And we do this using the colon. So we can say myString colon string, and this means that this is a string type. A second use of the colon is when we create a class and we want to inherit stuff from another class. We do this using the colon and then we define where it inherits it from. The third use of the colon is in functions. We define a function using the fun keyword, followed by our function name starting with a lowercase letter. And then within brackets we can have some parameters, some input variables. Then we can use a colon to define the output. In this case our output is a Boolean type. Finally, our executable type is defined within the curly brackets. There's much more in Kotlin than we have discussed right now. But you will see a lot more during the upcoming videos and in examples that you will create yourself. Before we move on to Jetpack Compose, I promise you that Kotlin in itself is more robust and especially concise than Java. So let's look at an example where we can really see this. The long if-else statement you see here on the left is how we would define an if-else statement in Java. This statement in itself we can make a lot more concise by using Kotlin instead. First of all, we don't have to define the result before we start our if-else statement, but we can have the definition as an output of the statement itself, cleaning up one line of code already. We can make this statement even shorter by using the when clause instead of the if-else clause. This way we use a line for each condition and directly say the output after an arrow. Now we went from 8 lines of code back to 4, which makes our code more readable and easier to write, which of course is nice. If you found this satisfying, or if you rather want to use Java instead, let me know in the comments. Now that we've seen the basics of Kotlin, let's move on to Jetpack Compose. Compose is a UI toolkit that uses a declarative approach. This basically means that we can tell it what we want to see, and Compose will do the rest and make it look nice, which means it is very intuitive for us to use. The code for Compose is also written in Kotlin, making it easier because we only have to learn one language. Previously, we had to learn both Java and XML to be able to code an Android app, and now we can only do it using Kotlin. Compose has composables as building blocks, and a composable is basically what we see on the screen. Now, any function we create in Kotlin can become a composable, simply by adding the composable annotation above the function. Please pay attention that when we create a composable, we use our naming to start with a capital letter, and the names of our composable should start with nouns. During all the applications you will build in the future, you will come across a lot of different pre-made composables, such as boxes, columns, rows, images, texts, edit texts, and much more. An important thing to note is that all of the composables can use a modifier. This modifier allows us to edit the generic attributes of a composable, such as padding, its size, and alignment of elements within the composable. For example, if we have a box like this, a box composable allows us to enter elements into the box, but in the box itself, it is not sorted. Now, if we have the modifier and we change that modifier, we can change the size of that box. So for example, if it is this size, we can say, okay, instead we're going to use a size of 10 centimeters, and your box will be smaller. I know that all of this is a lot, but Android Studio has built-in documentation that will help you along the way and see what you can edit inside of your composable. Often you also want to see that the stuff you programmed actually looks the way you think it will look. And for this we can use preview composables, a special kind of composable. We can turn a composable into a preview composable by adding the @preview annotation above our composable. And then if within the composable we reference to the composable we want to see, it automatically gets rendered inside of Android Studio, and when we make a change to our code, it automatically gets updated on the right. In general, this quick reactivity is something that Compose is really known for. The fact that it uses a lot of small building blocks allows us to only rebuild the building block of which the data has been changed. So if we have a complete screen showing a lot of details about the user and only the username changes, Compose is smart enough to only change that single building block instead of having to reiterate the whole screen, which takes a lot of effort. By now you've seen most of the basics of both Jetpack Compose and Kotlin itself. Of course, we haven't really seen how to build an application yet. As with any programming language, it is now important to learn by doing. So open up an Android Studio project, start playing around, see what you can edit, and create your own first application. Let me know in the comments what you liked most and if you would prefer Java over Kotlin. I will see you in the next video, where we'll dive deeper into the Android lifecycle and how Android builds its own apps.